A single ship the size of an aircraft carrier built from a commercial oil tanker hull can launch helicopters, drones, and special forces without ever docking at a foreign port. As military access grows more fragile worldwide, this floating base is changing naval strategy. Why are America's allies racing to copy this design, and what hidden risks come with rejecting traditional bases? The answer begins with a problem that no nation can ignore. Military planners have always relied on secure ports and overseas bases to move ships, launch aircraft, and supply forces. Yet over the past 2 decades, access to these fixed sites has become less certain. After 2001, the politics of foreign basing grew more complicated. Host nations began limiting what American and Allied ships could do from their territory, sometimes restricting operations entirely during crises. In regions like the Persian Gulf and the Red Sea, even long-standing agreements have come under pressure, leaving navies exposed to sudden shifts in local policy or outright denial of access. At the same time, the threat of mines, anti-ship missiles, and swarming small boats has made many coastal approaches dangerous, especially in contested waters where adversaries can close choke points or target ships gathering near shore. These realities have forced a new question: how can a navy deliver forces and supplies, launch helicopters or drones, and sustain operations if the next crisis shuts the door on every nearby port? The answer lies in building a base that floats, one that can move wherever it is needed, independent of any host nation's permission or political mood. The backbone of the Expeditionary Sea Base is a commercial hull, not a purpose-built warship. Each ESB starts life as an Alaska-class crude oil tanker, a design known for its reliability and sheer size. General Dynamics NASSCO, the San Diego shipbuilder, takes these 785-foot, 90,000-ton vessels and transforms them into floating infrastructure. The conversion process leverages the tanker's double bottom structure and proven propulsion system, which delivers over 15 knots and a range of nearly 9,500 nautical miles, enough to cross oceans without refueling. By starting with a commercial platform, NASSCO avoids the cost and risk of designing a ship from scratch. The result is a carrier-length hull with a beam of 164 feet, offering a stable open deck that rivals the footprint of some of the world's largest naval vessels. This approach keeps costs in check while delivering a platform big enough to host helicopters, drones, and modular mission bays. The commercial DNA is visible in every line of the ship, a deliberate choice that makes the ESB both affordable and adaptable for a range of missions. A ship's true value isn't measured by the number of missiles it carries, but by the space it offers for action. On the Expeditionary Sea Base, the deck is everything. Stretching nearly 1.5 football fields long, the 4-spot flight deck can launch and recover heavy-lift helicopters like the CH-53 or the CH-47 side by side, while still leaving room for drones or smaller aircraft. This aviation hub turns the Expeditionary Sea Base into a floating airport, able to run simultaneous operations that would crowd out most destroyers or amphibious ships. Below, the mission bay is a blank canvas. Modular tie-downs and roll-on, roll-off access let crews swap out payloads in days, not months. Rigid hull boats, unmanned surface vehicles, medical facilities, and containers packed with supplies can all be exchanged rapidly. The deck's wide-open design is no accident. It is the product. Navies see it as the ultimate force multiplier, a platform that can change roles overnight, support the latest unmanned systems, and keep helicopters spinning even when every nearby port is closed. In a world where flexibility outranks firepower, the Expeditionary Sea Base deck is its greatest weapon. Running a 90,000-ton sea base takes fewer people than many would guess. The core crew, Just 44 civilian mariners from Military Sealift Command handle navigation, engineering, and ship systems. For military missions, only 101 Navy personnel are needed to operate the flight deck, communications, and specialized tasks. This dual crew approach means the ESB can surge to accommodate up to 298 extra people in its mission barge, scaling up for special operations, humanitarian teams, or drone detachments as needed. The result is a platform that delivers the output of a much larger ship, but with a fraction of the permanent manpower. That efficiency has not gone unnoticed. Allied navies facing their own recruiting shortfalls are now studying the ESB crew model closely. The Royal Navy's multi-role support ship program, for example, is built around the same logic. A small permanent crew with the ability to scale up for missions. In a world where manpower is scarce and operational demands keep growing, this model offers a clear advantage. It is already proving attractive far beyond the U.S. fleet. The first operational Expeditionary Sea Base, Lewis B. Puller, joined the fleet in June 2017. Just over a year later, Herschel Woody Williams was delivered, followed by Miguel Keith in 2020. Each new hull arrived on schedule, expanding the class from a single experiment to a global workhorse. By 2024, 6 Expeditionary Sea Bases had been delivered or were in the final stages of construction, with the John L. Canley, Robert E. Simonek, and Sergeant Mateo J. Cafferata Jr. all joining the roster. These ships now support forward operations in the Persian Gulf, the Mediterranean, and the Pacific, showing the concept's reach well beyond United States shores. General Dynamics NASSCO's leadership, under Kevin Graney, turned the Expeditionary Sea Base from a one-off conversion into a repeatable production line. This program's ability to deliver multiple hulls in under a decade established the Expeditionary Sea Base as a fleet asset, not just a prototype, and proved that the idea could scale to meet real-world demands. Commissioning the Lewis B. Puller as a full warship in Bahrain in August 2017 was more than a ceremony. It unlocked a new set of missions that were impossible under its previous status as a USNS auxiliary. With the USS designation, the ESB gained sovereign immunity under international law, shielding it from port state inspections and granting its commanding officer the authority to conduct mine countermeasures, special operations, and maritime interdiction, missions that demand clear rules of engagement and the legal right to use force. The legal office at CENTCOM pushed for this status, citing the need to remove ambiguity for operations in the Fifth Fleet's high-threat waters. The shift set a precedent. Every subsequent ESB would enter service as a warship, not an auxiliary, giving the class legal flexibility that appeals to partners facing similar operational constraints. Affordability is just as important. Each ESB costs about $550 million, roughly a quarter of the price of a new amphibious assault ship. In 2019, the Navy secured a $1.6 billion contract for 2 more hulls, a figure that covers both construction and mission upgrades. This budget edge allows navies to field more platforms without sacrificing core capability. For allies weighing their own procurement options, the ESB's price point and legal status offer a rare combination: a ship that can operate at the front lines, execute high-risk missions, and still fit within the realities of shrinking defense budgets. The result is a platform that isn't just affordable, it is legally empowered to act, making it a model for navies seeking both reach and restraint. Expeditionary sea bases are more than ships. They are the backbone of a network that stretches across the world's most contested waters. In the Persian Gulf, an expeditionary sea base can anchor just outside the reach of coastal missiles, serving as a launch point for helicopters, boats, and special operations teams. In the Mediterranean, these floating bases fill gaps left by shrinking access to ports, keeping a constant presence even as political winds shift. Out in the Pacific, expeditionary sea bases operate near choke points and island chains, plugging directly into Allied exercises and distributed fleet operations. Each location is chosen for its ability to support rapid response without waiting for host nation approval or the slow buildup of shore infrastructure. The result is a web of forward nodes, mobile, persistent, and able to relocate as soon as the situation demands. This plug-in approach allows navies to project power and sustain missions where fixed bases cannot reach, shaping the tempo of operations in real time. Engineers and planners have already begun treating the ESB as a testbed for unmanned systems. During RIMPAC 2022, the Miguel Keith hosted 4 MQ-9 Reaper drones, 6 Sea Hunter unmanned surface vessels, and rotary wing unmanned aerial vehicles all at once. The modular mission bay showed its value, letting crews install launch cradles for unmanned surface vessels in hours, not weeks. To handle the surge in data from simultaneous drone and vessel operations, the team retrofitted a Ka-band satellite uplink, pushing bandwidth limits beyond what the original design allowed. On the flight deck, a new networked control node let operators run multiple unmanned missions at the same time. Post-exercise analysis revealed a 35% reduction in operator workload, thanks to real-time sensor fusion and distributed control. These results point to a future where the ESB is more than a floating base. It is a mobile nerve center for unmanned fleets, ready to adapt as technology evolves. In an era where access to foreign ports grows uncertain, navies seek platforms that can adapt fast, operate anywhere, and scale with new technology. The Expeditionary Sea Base isn't just a ship, it is a strategy for a world where flexibility is now the ultimate advantage. What would your nation choose?